What was the?
Okay, so we're on the air now for the July 2nd Structural Modeling Conference. And Janet, you had a question?
Excuse me. Trying to figure out which document I was looking at. I didn't realize my microphone was on. Let me.
Okay, all right. So today we're going to be discussing the current material in the read ahead for this month. And then Thomas Kirchvold is going to talk a little bit about the plans for upgrading and updating the SMP web application that we produced over the last couple of years. We're going to improve that this summer. Kevin's going to talk a little bit about the systematic review process, and then we'll talk about planning for future collaborative activities. So, I'll talk a little bit here about the current material and read ahead document. We've had some discussion about the read ahead from last month about the asymmetric and anti-symmetric logical properties. I think this is just really an excellent approach, and it's really important that we have these types of discussions so that the purpose of the tools, what the AMEI is used for, what's its primary value, how can it help us do analytical types of processes. Those are all things that we need as a group to kind of understand better. And we've proposed some ways of looking at that. Janet and Michael made some comments on that. They commented that some of the logical combinations were essentially in formal logic were invalid. And we agree with that basically the topology for the AMEI essentially just kind of lists all the permutations under certain types of formal logic. Some of those are not allowed. Our goal, though, is to, in the structural modeling process, is to go from informal natural language that people use every day in business and commerce and translate that or put it in proper coordination or relationship to the mathematical property. And so we can't, we're only looking at some aspects of the mathematical properties that are useful and map fairly directly to natural language. But the people that do that, the systems scientists and the systems engineers that work in the area of making this match, we really need to agree or understand among ourselves what those terms mean, how they're used, and then talk about the areas that we have in common and where we're basically are having a common approach and where we agree, and then areas where we disagree so that we can actually map that and start creating a more formalized body of knowledge. So that's kind of where we are now. We've been working on this since last December, so we're about 6-8 months into it. And I believe it's time that we actually started to summarize this information, put it together, and create the document and a technical report on how this can be used and how it can be applied, what are the issues associated with the AMEI and its application to structural modeling. So with that, is there any questions? All right.
Joe?
Yes.
Could you put up the Warfield paper that you sent, the binary matrices paper?
Sure, you can do that. Let me find that one.
We might have already gone over this, but it's good to keep going back and figuring out how to read this section,
Yes,
and this is
it's okay. It's very important. It's something that uh, I think has been misinterpreted. Has been not. I won't say misinterpreted. Let's say it's been interpreted by different people in different ways, and
right.
haven't
It's a
really.
source of confusion, right?
There you go. Okay, so let's try now to bring up share this one. Um, just for example, though, I think before I bring up the binary matrix, I'd just like to briefly show um, a mapping that I think we did when we first started back in November or December. And what it does is it shows the logical properties that were listed by Warfield in some of his earlier works from the Battelle monographs. And what I think is important here is that Warfield only listed 5, I believe, um, logical properties in the Battelle monographs. And the ones that he listed, I think, are highlighted here in green, so that he listed reflexive, irreflexive, symmetric, asymmetric, and transitive. So, and he didn't have the concept of putting them together in groups. I mean, they were grouped. You can, in different applications they were grouped, but the idea of having 3 at all times in the permutation groups is not there. So when you take the 5 properties that were listed in Warfield's work in the Battelle monographs, then what you find is there's only 1, 2, 3, 4 areas out of the 27 that are covered. So that's just kind of what I wanted to briefly talk about right there and show that. We talked about this, I believe, first last November, December. Now I will bring up the binary matrix paper. Let's share that. We'll have it right here. Okay, can everybody see that? To present to everyone, click that button. Okay. Everyone see that?
Oh
Yes.
no.
Okay. So what part would you like to discuss?
Well, I don't see it, but I have it in front of me. So it's the bottom right um, in Figure 2, last full paragraph.
Figure 2,
It
bottom.
says it starts out in Figure 2. It
Okay.
appears irrelevant whether the arrows are added on the loops at the vertices S1 and S2.
Right.
Now, so I think this is the key. He says, in many instances in the applications, the relation R is of such a nature, and the systems analysis is conditioned such that it does not matter whether one shows reflexivity or irreflexivity.
Well, R, I think R is the relation.
Right, but it's whether SI is related to SI or SI is not related to SI.
Right, exactly.
So that is the determining whether there are self loops on the nodes in the directed graph.
Right.
That is the determining factor that distinguishes asymmetry and antisymmetry. Antisymmetry allows for the self loops, and asymmetry does not. So asymmetry is the strict ordering condition. I think so. His point here that convenience can often be the deciding factor. Therefore, this issue need be considered only in a specific context. I think that if it were, and maybe in the literature review, one would want to talk about asymmetry and antisymmetry and reflexivity coming off of this paragraph, because he's saying that that one could, in practice, use antisymmetry rather than asymmetry, because whether there are self loops doesn't matter in practice on the nodes. I'm actually curious when he says in many instances in the applications, it doesn't matter whether one shows the self loops or not. I was wondering if Kevin knew of cases where it does, and I guess there are specific cases like, I assume circuit design or something like that, where you'd want to be really careful about whether there are self loops or not. But in general, I think our position is that antisymmetry is that's the broader, more tolerant property that would allow you to do the 27 cases with independent properties, and they would all be coherent, valid cases. Asymmetry is a tighter property than you need, and it raises this question of the invalidity of some of your cases, which would not come up if you were using antisymmetry.
That's very insightful, Janet. And it's directly to the point. And so the things, the ideas, and the concepts that I considered, that Mary and I considered when we made this decision on antisymmetry and symmetry, goes to the fact that antisymmetry has within it, embedded within it, it has a decision. You have to have information about the specific nature of the specific relationship between two of the elements. So it's if, A is equal to B, then within this case, you have this relationship in antisymmetry, right? The antisymmetry is, from our point of view, is more complex. It introduces more complexity into our considerations because of the uncertainty. And so you have to have empirical information about the element set before you can make a decision in antisymmetry.
Yeah, I think it actually, I think it goes the other way, because asymmetry is the stricter requirement. Every asymmetric relation is also antisymmetric. So within antisymmetry, you're not saying it's not asymmetric. It's a more tolerant case. If you it just says it doesn't violate the property if there are self loops or aren't self loops. So it allows both cases.
Right. So
it just doesn't allow symmetry off the diagonal.
Okay. So that's again. I think this is a perfect discussion.
We can let it. You can let it roll around, and we can talk about it later. But I wanted to make the case for that, and we can move on with your agenda.
And no, I think it's an excellent point. And the idea, though, is again the criteria that we use when we were looking at this was that because as you say, it's more tolerant, so it allows more configurations, and so for you to decide which configuration is going to be allowed in any real case, you have to have empirical data. And within that particular component of that information that you're gathering to make that decision, not only do you have a type of relation that has components of anti-symmetry, you also have a component, you also have a relation that has a component of symmetry, which is the equals. When things are equivalent, they are reflexive, symmetric, and transitive. So anti-symmetry also allows a symmetric component.
Only on the diagonal, though. And I think that's what Warfield is saying. That
I agree completely, but the point that I'm trying to make is it allows it. And so
right.
within this particular idea, you say, okay, we won't allow anti-symmetry. We can use equivalence because we have equals in there, and we can use asymmetry. And in our methods, and what we're doing here, we're actually combining logical properties and formal logic with the acquisition of empirical data. That's
right. So the data, as you're saying, the data would come from the interpreted model. It would come from the modeling context, and it's a question of articulating the difference between the relations that you get from the data, and then how those can be mapped into allowed matrices and what kind of insights you get. I think we should let this roll around and talk about it later, because I think it really does, it supports your comprehensive 27 categories better to not start out with some of them that are logically invalid by definition. It supports your comprehensive approach better to use anti-symmetry, but I'm happy to put that aside for now.
Yeah, that's no. So there are many factors involved. One's formal logic, right? The other is looking at the structure of a system that is getting information from groups of people in natural language, right? And so there are all these different facets and views that need to be taken into consideration when you're evaluating it. And I agree, we should put this on the side and go ahead and work the, but it should be a key aspect that we explore in the systematic literature review. So let's see, that's really good, Janet. I'm glad that we're having this discussion because it's real important. Okay, so now I'm going to stop sharing this one and bring up the agenda. Where did the agenda go? So, if I can find that. Let's see. Let's, okay, I need to be able to find, it's not the agenda. Maybe here it is. Here is the agenda. I found it. We'll bring it up. So Thomas, are you ready to have a discussion of the...
I think so.
Okay. Well, we have used up more than our 15 minutes, so it's your turn.
Okay. I'm Thomas, and I'm working with Joe on the SMP web application development process. And we're currently reviewing the work that was already done with the 19 cities problem, and just in the process of re-architecting the code supporting the mathematics behind that entire process. We're wishing to create a library to support the basic different categories of logical relations in the AMEI, and should have a draft coming up in the next couple of weeks to guide that process along. And we're looking for people to basically supply requirements and then eventually test the system once it's ready.
Okay, is there anything else you'd like to add, Thomas?
Not at the moment that I can think of.
Okay, well, thank you. I'm going to add just a few little details around that so that maybe place it a little bit more context. So anyone that's a professional programmer that looked at the web app that we put out there, it's definitely a proof of concept system that was hacked together fairly quickly in JavaScript and HTML5 to demonstrate these ideas and thoughts and concepts and get the graphics up on the screen to help promote and communicate these ideas. So what Thomas is doing now, and the goal of this is we're going to make this into a more modular type of approach. So we'll be extracting the mathematics pieces out and putting them into their own libraries. And we'll make it more compartmentalized so that it can become fundamental components that can be used in other applications if people wish. Or we can have a number of different types of web applications that are driven by, that are all use the same type of library. So we're going to make this more modular. We're going to bring it into more modern, single-page type of web application development and work that forward. That said, we're really going to need some input from the user community on what kind of user stories, what kind of user interactions, the most basic things that they'd like to see, so we can start focusing on that as our next series of activities once we re-architect and the basic structure of the system we have now, make it more modular. So is there any questions from anyone on that? Okay. Well, we'll be planning on presenting that and giving that information out. We'll have that out next month for sure. And hopefully it all will go well, and it will allow us to maybe explore visually and in a natural language transform to a mathematical transform some of these concepts of asymmetry and anti-symmetry. Okay, so Kevin, let's like to discuss the systematic review process.
Okay, so are you handing control over to me to do the screen share?
Well, you know, why don't I do that? So I'm going to take the presentation away. I'm going to go to the control room and to Kevin Dye. Let's see. Okay, so I need to see, we've done this before, right? And I just need to figure out how I did it before. So, well, right now, Kevin, let's see. The screen share, I'm not quite sure.
So I can hit the screen share here.
Okay, you do it. See what it does. Oh, there you go. I see it.
Yeah, okay. So the first step in doing the systematic review, which was I had proposed as a format for developing a journal article, was to establish the purpose for doing the review. And we started contextually with what's the purpose of the project, because I didn't know if that had really been articulated. It's kind of been implicit. So, did you see a change to the purpose of this project?
Yes.
Okay. So, this was from the two last NCOSE presentations we did on the project, plus additional contributions from Mary and Janet during one of our online sessions. And this is the whole endeavor. Now we need to kind of circumscribe the purposes or the purpose of the literature review or the review paper. And and then the next step is to identify the criteria by which literature is included or not. And I'm not sure exactly how to do that. So maybe we should have just people unmute themselves and contribute their ideas of what the purpose of a systematic review paper is for this area. You want to start, Joe?
Sure, I can start while other people are thinking about it. I think in my mind, the most important part of the systematic review is to, again, establish the criteria, is to do a review and a search that elicits the criteria that says, okay, this is how we know that we have placed these types of mathematical theories in proper relation to real-world types of problems. So we've got classes of real-world types of problems. We have the mathematics there. The connection between those is we need to figure out what are the criteria that says, okay, we know we put these in proper relationship. And so that to me is the fundamental key. Now, what does that mean? You know, that could be a lot of different things, but we would need to look at that. And I don't think a lot of people have really done that in a general way. So, anyone else have any ideas?
Yeah, am I on now? Okay.
Yep.
Yeah, I think I got some comments from people who had seen this on the discussion list, the working group, system science working group list, that they were overwhelmed by how much there was on this. Now, so I think it might be, and I pointed out that it's really the near-term objective is to address the top part of the list. I see it, and maybe add in if what Joe just said is not adequately expressed there, some kind of standards for the whole modeling framework, so that it's not just the mathematics, but the use of the mathematics in modeling activity is standardized. That needs to be done with an eye to taking on the rest of the list. So you want the near-term objectives of clarifying the mathematics and the modeling choices, including things like the AMEI, to be sufficiently clear that it supports taking on all the rest of those objectives. So it might be good to separate a couple of those two near-term objectives, standardizing the mathematics and standardizing the modeling choices, and say, if if we don't have the rest of the list in mind, we're not going to do that in a sufficiently general and robust way. And that's been the problem in the past when people have standardized their own approaches, but have not, considered the whole universe of these modeling activities.
Which numbers would you say are the focus? Number 1?
Certainly number 1. Now, so which would maybe 6? I mean, which one captures what Joe said about what is being done and some kind of validity standards for modeling choices, going from natural language to graph to a matrix and back again.
I think that's number 4.
See. Lost the list now. Let's see. Oh, there. Okay, 4. Yes, 4. Yeah, so maybe 1, 4, and 6. So, and then that sets up 9. The Hammond quote, and then maybe the rest are what you want to support. So the maybe 1, 4, and 6 are maybe they're descriptive and achievable, just with the review of what's already been done, something like that. Right. So that if 1, 4, right, 1 and 4 are key foundations. 6 should be what you're able to do with the standard approach, is to show how a given case is making use of those elements. Of course, that would be a huge achievement in its in its own right, just to have those.
Yeah. So more specifically, then, I mean, that's 1, 4, and 6 is the focus of the overall project. What is the role of publishing a paper about it? What are we trying to do with the paper towards those ends? So one thing I thought first is just to point out the variations amongst the different families of Boolean matrix methods. I think is a start of the paper.
Yeah.
So just to actually do a survey of...
I think that is... Joe, did you finish?
Well, I'm
going to say that what you're showing that there. I can't hear Joe. Am I?
I'm not talking, so.
Okay. I thought you finished. I thought you stopped in mid-sentence.
Oh, no, I didn't. I'm leaving room for other people to talk.
Okay. Okay. um, that what Kevin just said there, and the fact that that achieving agreement, showing is the only way to the lack of progress of agreement is uh, so yeah, I don't think I don't remember if I heard where you're talking about publishing the paper, but I think that is I think showing the sources of confusion or the lack of agreement in the foundations is would be a very interesting paper in its own right. It doesn't have to be terribly long, but just collecting some of these cases together and showing why there has not been progress. That's people. I hear from so many different systems communities that I participate in. People are continually perplexed why we can't build on each other's work, and it's because we have not clarified exactly what it is that we're talking about in some kind of standardized way, and so achieving that in a paper that people could point to would be very useful, I think.
Kevin, I think that there's something that I would like to see in this paper, and it's probably already covered in what you've spoken about, but that basically entails not just the introduction and the demonstration of the foundation, the isomorphisms and so on, but also point out where the general can be used as a basis or a framework, but then get some particulars about where you would develop context-specific information, such that people can understand that this is where their particular domain would take off. I'm not sure that that's expressing it very well, but I'd like to be able to see that.
Well, Mary, just to talk about that and to expand on that thought, and also to refer back to what Janet has said about the binary matrix paper. Essentially, it said these particular, some of the applications are, whether or not you use this mathematics technique or that mathematics technique, depends upon the specific context and convenience. So what type of tools are you using? How do you think about it? How does the group think about it? So I think that might be an example of what you're talking about.
Yes, I think so. My larger concern is not to produce a paper that is so broad that people can't find a way then to start identifying about where their particular work could fit as part of, or use this as a part of their own methodology. And so what I'd like to do, I guess, is see those linkages between the higher level foundation, and this is a way that we can all agree is a good place to start, but also provide some specifics, some specific cases that have already been developed that show how that context then is developed inside of the larger framework.
I think it might be good to split that into two papers, two compact papers. I'm trying to remember, back in the 80s, I used a decision tree. It's very comprehensive of statistical techniques. It was a book, fairly short book, and it said, if you have discrete data and you have this condition, you have that condition, and it guided you through
Yes.
the available techniques. That would be nice to aim for.
So I think that's a good list to go with right now. I tried to take notes on that, and I'll send them to the recipients of this the news about these conference calls. So next is how do we circumscribe which literature is in and which is out. Now, Joe has kind of done this by saying, these 3 or 4 particular authors are the key ones: Stewart, Sage, Warfield, Hitchens. But I'm not sure if that's a valid way to circumscribe it in terms of a systematic review. You have to kind of say we reviewed all of these similar techniques, and I'm wondering if one of the problems is a lack of standardized terminology, making it difficult to run a search. I'm not sure what the key words are that would be our search. Is it all Boolean matrix methods? Is it all binary matrix methods? I'm not sure. Or if we should focus on specific techniques within those.
Well, that's a very interesting set of questions, Kevin. And after we had our discussion earlier in the week,
Yeah.
I ran some preliminary kind of test recon searches.
Oh, good.
And what I found in those specific searches are, one, if you just look at everything that is kind of associated with a Boolean or a binary matrix, you get a 0-1 matrix, a whole series of literature there. You get a circuit theory type of approach. There's probably a dozen application-specific names for those areas that have a lot of literature with them. The current interest in big data and how you filter massive data sets is also generating a tremendous amount of work on the Boolean or the 0-1 or the binary matrix selectors. And they're using those selectors on object attributes. So a lot of the material that's foundational in this area is specific to a discipline or an application. One of the key factors that I thought about once I had done the recon searches and the recon kind of overview is that we're really talking about a specific type of application of a binary matrix. And we're talking about the application of a single structuring relation over the system data. And so if we kind of do that, if we focus down on the Boolean 0, 1, or binary matrices, whatever the circuit theory things are called, but we restrict it to the application and the development of a system structure that uses a single binary relation between the elements. Then that cuts it way down. That cuts it way down, because many of these mathematical techniques you can use to filter the attributes of extremely large collections of data, which really have nothing to do with the focus here that we're doing, which is trying to understand and make obvious and communicate a hidden, unknown, or poorly defined system structure. So that's as far as I got going down that path.
So is a single structuring relation a highly repeated phrase?
No. it's the the binary matrices here, the paper that we reviewed earlier, and kind of outlines an approach. And what you're doing there is you're going from a mental model in your mind, or in the mind of a group of people, 10 people or 100 people or 1,000 people, of this mental model in your mind, and you're trying to create a more formal model of that structure. And you're using a system structuring relationship to do that. So if you use that particular approach on the as a sub-filter within these methods and techniques, then we may be able to get a more manageable size of literature.
Yeah, you certainly, I think the reachability matrix is a way to identify a single relationship, the relationship of being connected, no matter how many relationships there are in your original data collection. But what we do want to focus on people who are talking about that single relationship, the value of modeling with that single relationship matrix. So I don't have any good ideas on how to cut down the search, but I think you certainly could start with just the people that Joe suggested, and then we could maybe have some way of adding people. I don't know at what point you might take this effort public and have have a way for people to make suggestions in a wiki, or I think I have a book that I haven't looked at that came out a few years ago on dependency structure matrices that I think tries to be comprehensive, but I think it's good to start with where Joe suggested, and then we can iterate on that.
All right, so we have about 11 more minutes left, so down to the that enough information, Kevin, for us to have some more definitive next steps for the group?
Do you see the template?
I do.
Yeah, so number 4 is the selection criteria.
Yeah.
And we kind of talked about what the inclusion criteria is, but there's not really a standardized set of terms unless we just, can discover the related terms through the types of trial searches that you're doing. But yeah, I think the single relation thing is a differentiator. There's a lot of systems modeling techniques. They like to point out how many different relations they can include in them.
Yeah.
And as a result, they tend to push the user into modeling very local things. Whereas, to me, the value of using interpretive structural modeling as a front end is that it considers relationships across the entire set of ideas rather than pushing you to put lots of detail into localized relationships. So along with the inclusion criteria, is coupled the exclusion criteria, like you were saying, things related to big data and multiple relations, I guess, would be an exclusion criteria, even if they're talking about a particular relationship.
Right, and that's also what one finds in the concept map and mind map kind of approaches, is that any and all relationships are considered, and anything is considered a node, anything is considered a relationship, and you end up with all of this, extreme locality, as you're saying, rather than the whole idea of this approach is the globality that you can achieve if you are disciplined enough to identify what your nodes and relationships are.
Yeah, when I was thinking of how to constrain what literature would be in with and without, I was thinking that, to me, the most powerful thing of Warfield's, I think, Christakis' structural modeling is the construction of the matrix. And whereas Stewart's stuff and dependency structure matrix, they focus on what you do with the matrix once you have it. Right, and so I was wondering if we can narrow it down to a specific technique, like I think Warfield calls it cybernetic embedding in one place, transitive bordering. You know what I'm talking about, Joe?
Yes, and I think it's also in the paper that in the binary relations what's the model exchange isomorphism, and where Warfield talks about, okay, I have an idea in my mind, or there's a group of people that have an idea, and this is the way we construct this matrix step by step to make the structure and to make the idea and to make the system more apparent to everyone. So there's this one. There's another list that was done by Sage where he expanded on that, of going from the mental model in your mind, all the steps you go through to create the matrix. And so that might be another great discriminator and filtering mechanism that says, okay, we're going to look for techniques that start with just a very fuzzy, undefined idea among a group, and then, or an individual, and then it allows the person or the group to create a more defined, definitive structure. So, in a matrix form, or structured graphics form, which are interchangeable. So yes, I think that's construction of the matrix is a good discriminator.
And it should be should it be only looking at techniques which have the digraph and the matrix?
Well, they're interchangeable, so if you got one, you got the other.
I know they're interchangeable, but Stewart, in the dependency structure matrix, they often ignore the digraph.
Well, they don't. Okay, so the thing about the dependency structure matrix is they don't have a Boolean matrix. What they have is they have a matrix that has a bunch of entries on it that have different values, 0, 1, 5, 9, 7, and all these things have different semantics. So the DSM, as it sets in that case, is not a strict Boolean matrix. So Mary and I took that whole thing apart and pulled out the structure piece and made that, you can make that into a Boolean matrix, which we call the marking space. And then you can have all these other semantic things mapped over that. You can map that into other graphics, but DSM doesn't do that. They mix everything. So it's so I think we should really first just stick to the Boolean binary matrices. And then once that solid foundation is agreed to, then we can have more detailed discussions about why things that use different numbering systems and different mathematics are different.
Right. I don't think they would need to be included in the first at the first cut. That would again be a more, a next objective would be to expand to that kind of work. But I agree that Boolean and binary is what we want. What we want are the people who focused on developing that. Now we have two themes that go along with that, which is the group modeling. Do we want to focus on the people who use this as a group modeling effort, or or is it just Boolean and binary that is the first criterion? Yeah, I don't know. Yeah.
So there's a couple of different techniques involved there, and I think the foundational piece we should stick with the mathematics, and then how the mathematics are interpreted and presented to the group would be a second type of area to focus on. Very important, but I think they're kind of separate in our language interpretation thing.
Right. So then the use of the graphs is often part of the group modeling effort, or building toward incremental construction of a model. So for Kevin's question about do they need to use both graphs and matrices, I think you're saying no, that they just need to use the Boolean or binary matrices, and whether because the graphs are more of a support tool than a distinguishing element.
The mathematics is done with the matrix, and the graphics are usually used to communicate the mathematics. So, but there's things that we can look at there once we get the basic bounds figured out. So, Kevin, do you have enough to give us some marching orders for next month?
Well, next month I wanted to, along with this, start to get into part-whole relationships, so a specific application
Okay.
of the structure. So, and that's, I'm not sure how far we're going to get into natural language mappings in this review paper, or is that like a third paper?
That's like a third one. And I'm just, we had, I sent out a list of online bibliographic systems. And so maybe one of the things that we as a group should decide to do maybe within the next week online, the people that want to participate in this process, is look at those bibliographic offerings that are online and select one, and then we can start, roughly filling out this criteria, and so we can, start getting some lists and getting some information into that bibliographic list.
Right. Yeah, I'll try to compose our answers to these to this protocol and see where we're at.
Excellent. Well, our hour is up. Is there any burning issues that people would like to talk about before we sign off? We can have other, email conversations as we develop these specific parts of this. I think we're making tremendous progress. So Janet, anything else you'd like to discuss or emphasize in this meeting?
No, I agree. We're making progress. I think we've definitely identified some of the key sources of confusion in sharper form, and I really like the way both Kevin's work and Thomas's work, everything is exciting.
All right. Thomas.
Joe.
Anything else you'd like to add before we close the meeting?
Not at the moment.
Okay. Thanks, Thomas. Mary.
Joseph.
Yes, okay.
I was just going to say, it looks like August 6th. I'm looking at the calendar. That's right in front of my computer. It's going to be our next meeting. So, and Kevin, I think you said mirrorology, the parts thing. Is that right?
Right, Miriam.
Miriam. Okay.
All right. And I know that Janet found the link that I published online useful, so I'm going to advertise the August broadcast online and do it in multiple different ways, so maybe people can find it easier to log in.
Oh, also, I was going to ask about moving to 9 o'clock.
9 o'clock sounds good to me.
Yeah, it's fine.
Okay.
My impression with Thomas is anything that he doesn't have to get up early in the morning for is better.
Yeah, 9 o'clock is always a more wakeful hour.
Okay, 9 o'clock it is. We'll move it to 9.
Okay, bye-bye.
Okay. Well, until we get some information here from Kevin, and we'll circulate some of the ideas on the. Did everybody look at the bibliographic list? Should I send that out again?
I could use it again, yes.
Okay, I'll send that out again. All right,
you
well,
also,
this is great.
Joe, you might want to, if you're keeping attendance of these, I don't know, Michael is always here as well and contributing. We just didn't want to have feedback, so he's not on as a separate person, but you do have one extra person on your team here.
Okay, great.
Okay.
Yeah, we are there. That's good to know because it's all recorded and everything. So you should just have him say hello once in a while.
Right, that's true. Okay, well, he can say goodbye at least.
Okay. Goodbye, Mike.
Bye-bye.
Have a
Thank
good
you.
Fourth.